So we have already talked about the black body radiation. We have also talked about the transmission, reflection and absorption coefficients. In this class, we will touch specifically only deal with the emissivity of the black body and the emissivity of other objects with respect to or with regard to the black body radiation. So when we say emissivity, what do we mean by emissivity? So emissivity actually means that it deals with the emission from a black body. So we know that the black body is the ideal emitter of radiation, which means that once it has reached the equilibrium, okay, so black body in equilibrium means that it is throwing out the same amount of light that it is, same amount of radiation as, in terms of energy, it is radiating the same amount of energy as it is absorbing. So that is the black body in equilibrium. So when the black body has reached its equilibrium position, reached this equilibrium, then its emission is the largest of any other bodies at the same temperature. So if I take this remote, for example, it is not a black body. I take it to a particular temperature, it would start radiating certain amount of energy. This amount of energy would always be less than the amount of energy radiated by a black body at the same temperature. So that is the characteristic, or that is the important property of the black body radiation. So another important property of the black body radiation is that it depends only on temperature. So in this graph, we have shown the spectrum emitted by the radiation spectrum of the black body radiation, which means that how much energy relatively is present at a particular wavelength. That is what this graph shows. And this particular radiation profile is characteristic of the black body, and it depends only on the temperature of the black body. So no matter what the shape of the black body is, if I take it to, let's say, 3000 Kelvin, then this is the kind of radiation profile you would get at a particular wavelength. How much energy is thrown out would resemble this particular graph at 3000 Kelvin. 4000 Kelvin, this is the graph that you will get. At 5000 Kelvin, this is the graph that you will get for the radiation from a ideal black body, or for the black body radiation. And this particular law is known as Planck's law. So what is Planck's law? Planck's law says that at a particular temperature, the radiation profile of the black body would follow a particular curve, a distinct curve, and that would remain the same for all the black bodies at that particular temperature. Okay, so that is the radiation law. The important property that we discussed together with the Planck's law is that the radiation emitted at a particular temperature by the black body is largest of any other bodies. Okay, so if I take all the bodies to that particular temperature, the black body would emit the largest amount of radiation. We call that radiation, we give it that radiation, based on that radiation, we define the emissivity. Okay, it is denoted by epsilon, or sometimes it is also denoted by E. And the emissivity is actually the radiation emitted by any body, okay, divided by the radiation emitted by black body at the same temperature. Okay, same temperature. So by definition, the emissivity of the black body is actually 1, because the black body radiation emitted by black body, so the numerator and denominator become the same. So the emissivity of the black body is 1. All the other bodies, since they emit lower energy than the black body at the same temperature, okay, it means that all the other bodies have an emissivity of less than 1. Okay, so that is what we need to remember when we talk about the emissivity. Okay, thank you.